I want you to look at the problem in red. Okay, that takes us back to January where we got started. How would I solve the problem in red? I have 1/2 n plus 3/4 equals 13/4. How would I solve that?
Would you bring the 13/4 to the other side of the equal sign?
I would not do that. It's not crazy, but I would not do that. Jennifer? Or Jenny?
Find the least.
No, that's right. It is least.
Least common denominator.
Correct. You would find your least common denominator. Then, what would you do with that least common denominator? Multiply everything by that least common denominator. Okay? So I've got a 3, I've got a 2, I've got a 4, and I've got a 4. What's my least common denominator for my equation in red? Least common denominator. Colby is 4. You've got to make sure, you're thinking greatest common factor. Greatest common factor would be 2. Least common multiple, that means the 2 has to go into it and the 4 has to go into it. Okay? Students get those two mixed up a lot. Okay, so what we're going to do here is we are going to multiply all of this times 4/1. Okay, so I have 4/1 times 1/2 n plus 4/1 times 3/4 and then 4/1 times 13/4. So the stuff in red is my original problem. The purple is the 4/1. Okay? Now I'm going to simplify. And when I do that, when I simplify, I eliminate the denominator. Okay? So 2 goes into 2 one time. How many times does it go into 4? 2. Good. So then I'm left with 2 times 1 times n. Okay? Here, my 4's cancel. What am I left with there? Yeah, 3/1 or just 3. My 4's cancel again. And what am I left with? 13. So now I have 2n plus 3. And I know how to solve that. When we multiply everything by my least common denominator, that's what we get. We get rid of that denominator. And that's what we want. We want to get rid of them. Okay? So, I'm going to finish solving this. I subtract 3 from both sides. I end up with 2n equals 10. So what's n? 5. Okay? Now, we did this in January. I know you may not remember, and that's okay. But we did it in January. We are going to use that same principle today. But in a few minutes, we're going to throw some variables and we're going to throw some binomials in there. Okay? Give your brain time to process this lesson. Okay? So definitely work on it over multiple days. So, what I'm going to do now is I am going to decide what my LCD is from 3, 4, and 6. So I am looking for the smallest number that 3 goes into, that 4 goes into, and 6 goes into. It's got to be a number that all 3 of them go into evenly. It is 12. Good. It is 12. So I am going to multiply this by 12/1. Okay? So I have 12/1 times x minus 2. I am going to go ahead and put that in parentheses just to make sure we don't lose anything. Okay? Then I've got 12/1 times x plus 1 over 4 equals 12/1 times 1/6. Okay? Now this time I did it opposite. The purple is my original equation. Okay? The purple is my original equation. Okay? So now we're going to simplify. We're going to clean up. Okay? 3 goes into 3 one time, so it cancels. How many times does 3 go into 12? 4. So now I'm left with 4 times x minus 2. That's why we put that parenthesis there. That's why we put that parenthesis there. Okay? 4 goes into 4 one time. How many times does it go into 12? Good. Okay? And 6 goes into 6 once. How many times does it go into 12? 2. Okay? And we know how to solve this. We know how to solve this. Okay? We distribute the 4. 4 times x is 4x. 4 times negative 2 is negative 8. 3 times x is 3x. 3 times 1 is 3. Okay? So I end up with 7x. So 4x and 3x is 7x. Negative 8 and positive 3. What's that? Good. Okay, this is looking familiar, right? Once we get rid of those denominators, it's not too bad. What's x? Good. X is 1. Now we can go back and plug that in and check it. Sometimes the checking in fractions is a little bit more difficult than the actual solving the problem. Okay, so let's try this again. Can I move off this? Okay. What do you notice is different about this problem? What's different?
There's an N.
Good. There's an n in the denominator. We have a variable in the denominator. So when I have a variable in the denominator, that makes it a rational function, a rational equation, because I have that n in the denominator. The very first thing that I have to do is I have to determine what n cannot equal. Okay? So I've got to determine what n cannot equal. Okay? And that equations with a line through it means does not equal. Now, I want you to take your phone, pull up the calculator on your phone, and I want you to divide 5 divided by 0. 5 divided by 0. What do we get? Error. Okay? What are we not allowed to have in the bottom of a fraction? 0. Okay, so I've got to throw out all values that make my denominator 0. So in this case, what value for n makes my denominator 0? 0. Okay, because I don't have anything else in there. I just have n. Okay, so n in this situation cannot be 0. Now, when we finish solving this, we've got to go back and check to make sure that our answer is not 0. Because if we get an answer of 0, we have to throw it out. Okay? Okay, now my second thing that I have to do is I need my LCD. I need to determine my LCD. So, everything has to be accounted for one time. Okay? Has to be accounted for one time. So, to find my LCD, I'm going to look at this denominator right here. What's in that denominator? N. 1 n or n. So that's got to be part of my LCD. What's right here? 2. So that's got to be part of my LCD. Now, do you see how I have another n right there? I'm good. I don't have to write it down again because it's already accounted for. Okay? So, now that I have my LCD, my next step is to multiply everything by that LCD. Okay, so I have 2n over 1. So I'm going to multiply every single term by 2n over 1. So I have 2n over 1 times 5 over n, 2n over 1 times 1/2, 2n over 1 times 9 over n. Okay? Now, if it's in the top and the bottom, I can simplify. That stuff we did on Friday is going to come in handy. So I have an n and an n. What am I left with? 2 and, good. Here, I've got a 2 and a 2. What am I left with? N. You could put n times 1 if you wanted to. I typically don't unless I just think you guys need to see it, but I usually leave it as n. Now, and then I've got it equal to, and my n's cancel. So what am I left with? 2 times 9. Now this is much nicer. Much, much nicer. Okay? So I get 10 plus n equals 18. So my value for n is 8. Good. Okay. So let's talk about what we just did. So the first thing that we had to do is we had to determine what n cannot equal. We had to determine what n can't equal. Okay, and we determined that n can't be 0 in this situation. Ultimately, our denominator can't be 0. In this situation, that the value 0 is what made it 0. Okay? The second thing we did was we find our LCD. Okay? And that LCD is going to include variables now. We find our LCD. Third thing, we multiply all terms by the LCD. Okay. Our fourth thing we did was we simplified. And after we simplified, what did we do? Solved. Now, the last thing that you've got to do is check your answer with I'm going to put x cannot equal numbers, okay? Because usually we use x a lot. I know in this we used n, okay? But you've got to take this 8 and compare it to that 0. And if they match, you have to throw it out. And we're going to have one like that in just a second. But you want to get in the habit of taking your answer and comparing it to what your variable can be. Question? No? Okay.
So we may go to this in just a second, but like when you're finding the LCD, so if there's like an X, a Y, a 2, a 3, and a 4, you have to do all of them?
You won't have an x and a y because you can't solve
Well, yeah,
for both. But you would have to, if you've got a 2, a 3, and a 4. You've
got
got to have everything with your LCD. Jenny?
Same question.
Okay, same question. Good.
And if they're like terms, you just go ahead and combine them. That's fine. Get the, if like some of the LCDs are like terms.
Like if it's 2 and 3 and you multiply? I would not, actually, because one of the things that we're going to have to do in a minute is factor our denominator. And once we factor it into those individuals, I would not multiply those out until that stage where we're simplifying everything. Because things are going to cancel out. And you want to have it in the simplest form to cancel them out. That's a great question, though. All those. Good job. Okay. Here we go. Now, what I want you to do right now is I want you to determine the value that x cannot be. What is the value that x cannot be? Then I want you to tell me my LCD. Okay? And don't make this more difficult than it is. Kind of go with your gut feeling first. So determine what x cannot equal, and then determine your LCD. Okay? So, what can x not equal? 0. Okay? X can't be 0. Okay? What's my LCD? X times 1. Yeah, it's just x. You can put the 1 there if you want to. You certainly don't have to. Okay? Now, if you get a problem that looks like this right here, what should I put that 7 over so that I don't get confused? Put it over 1. Okay? So if your problem looks like that and it just has a whole number or an integer, you put that over 1 immediately so that you don't get confused. So my next step is going to be to multiply everything times x over 1. Okay? So I have x over 1 times 35 minus x over x. And I'm going to put that numerator in parentheses. Okay? Then I have x over 1 times 7 over 1. Okay? X over 1 times 3 over x. Now, the good news is all these denominators are going to cancel out. Okay? So my first term, I'm going to cancel the x out. And what am I left with? Excellent. 35 minus x. Okay? I don't need to cancel anything out here. So I've just multiplied my x and my 7 together. I like to write that as 7x, not x7. Okay, again, here, my x's cancel out, and I'm left with 3. Okay, now, in general, I've always said, move your x to the left, move your x to the left. This is like glaringly that we should just add x to both sides. Would you agree? Yeah, I mean, I cannot justify subtracting 7x from both sides when we've got something like this. Okay, it keeps it positive, it makes it nice, it makes it neat. So I'm going to add x to both sides. So I have 35 equals 8x plus 3. Okay, what do I do now? Good. So I subtract 3. 32 equals 8x. What is my x value? Good. So x equals 4. Is that the number that makes x undefined? No, so we're good. So my answer is 4. Yes, sir.
So if you do, like, if you get 0, does that mean you did it wrong, or is it like just a different process?
It does not mean you did it wrong. It just means you have to throw that number out. Do you remember when we did word problems and we were dealing with the Pythagorean theorem? And when we got a negative, we couldn't have a negative length, so we had to throw out those negatives. That's what this is. This is an extraneous solution that makes it undefined, so we have to throw it out. It absolutely does not mean that you did anything wrong. Now, if you are getting the same thing to every single problem on the test and you're throwing every single thing out, you've got no solution on every one, you're probably making a mistake. There won't be more than one that you have to throw out. Okay? Yes, ma'am.
On the last one, you put, I think, nx over 1. Are we allowed to do the same thing with this, or just completely take out the 1?
I'm sorry, say that one more time.
On this question, you put,
2n over 1? Okay, and you're wanting to know, can you put 1x over 1? Like that? Yes, absolutely. Absolutely. 1x and x are the very same thing. Okay? Okay. Now we're going to move to where we have binomials in the denominator. Okay? This is a binomial. They have to stay together. They have to stay as a unit. A minus 2 is a factor, but it is a factor as a minus 2. It's got to stay as that binomial. Now, if I were to plug 0 in for A, if I were to plug 0 in for A, what do I get right there? 3 over negative 2. And is that okay? 3 over negative 2 is fine. I just can't have 0 there. Okay? So what value of A, so I've got A minus 2 cannot be 0. So what value can A not be?
2 or 1.
2. Yeah, you're right. It can't be 2. Okay? So A can't be 2. And we've got another one. What else can A not be? It's not 1. Negative 1. Okay? So it's negative 1. So all I did was I put this equal to 0 and this equal to 0, and that gives me my values that x can't be. Okay? You can't have x in the denominator. Your variable being 0, you can't have 0 in the denominator, sorry. Your variable being 0 doesn't matter at this point. Okay. Now, your LCD is binomials this time. It works the exact same way. What is my denominator in that first one? What's my denominator? A minus 2. Okay? What's my denominator in that second one? A plus 1. Okay? That's my denominator right there. Okay? Those binomials have to stay together. Now, I would not FOIL these. Okay? I would not combine them yet. Because when I start multiplying here, things are going to start canceling out. Okay? So I have A minus 2 times A plus 1 over 1. That's what I'm multiplying everything by. Okay? So I have A minus 2 times A plus 1. All of that's over 1. And I am multiplying that times 3 over A minus 2. So now I have A minus 2 times A plus 1 times 4 over A plus 1. Now, by design, it's what we want to do. We're going to start canceling these things out. Okay? So, A minus 2 and A minus 2. I'm left with a 3, and I'm left with an A plus 1. What am I going to have to do with that 3? Excellent. I'm going to have to distribute. Okay? Now here, my A plus 1 and my A plus 1 cancel. What am I going to have to do with that 4? Distribute. Now, you know how to solve this, so I want you to solve this right now. Did anyone look at this and say, oh, I could do cross multiplication? Did anyone think I can do cross multiplication with this? Okay, you can do cross multiplication with this. The reason that I like to do this one this way is to get you starting to think about common denominators. You can only do cross multiplication when it's set up as a proportion like this is. As soon as we have two rational expressions on the same side, you can't do cross multiplication anymore. And so I probably wouldn't even go there. I would get in the habit of doing these with your least common denominator. But if you're thinking, oh, I can do cross multiplication, you are not incorrect. You can do cross multiplication. Okay? So let's keep going. I have 3a plus 3 and 4a minus 8. All I did was distribute. Okay? I am going to go ahead and move it to the left this time. If you subtracted 3a from both sides, you're fine. Okay, so I'm left with negative 1a plus 3 equals negative 8. Okay, so I have negative 1a equals negative 11. What's a? Good. Is that my undefined values? No. So I'm good. I'm good. Okay. Can I go to the next one? Okay. Good? Okay. Now, I'm going to give you about 1 minute. I want you to tell me what is it that A cannot be, and I want you to tell me my LCD. Okay? 1 minute. You are determining my LCD, and you are determining what A cannot be. Okay, what can A not be? 2. It can't be 2. All you have to do is you have to put A minus 2 equals to 0 and solve for A. That's all you have to do to determine that. What is my LCD? Yes, A minus 2 times 3. So right here, I've got A minus 2. And go ahead and put that in parentheses. Okay, put that in parentheses. Then right here, I've got to account for that 3. Okay, so you have to account for everything. Do I need to write this down again? No, I don't. I don't need to write that down again. Okay, now we are going to multiply everything times 3, A minus 2. So I have 3 A minus 2 over 1 times A over A minus 2. 3 A minus 2 over 1 times 2/3. I always think I'm going to write smaller, and I never do. 3 times A minus 2 over 1 times 2 over A minus 2. And hopefully you can see that purple is your original function that we start, or your original equation that we started with. And now we're going to clean this up. We're going to simplify some of this. So I've got A minus 2 and A minus 2. So I'm left with 3A. Here, I am canceling out my 3's. What do I have to do with that 2? Good. And then what process am I going to do with it? Distribute. Excellent. Excellent. Okay. Then for my last one, I just have 3 times 6. Or I'm sorry, 3 times 2, which is 6. Okay. Now we can clean this up. 3A plus 2A minus 2 equals 6. Okay. 3A plus 2A. Whoops, I forgot my 4 right there. I didn't distribute. Do you see that? 2 times A is 2. 2 times negative 2 is negative 8. Or I'm sorry, negative 4. Okay. 3A plus 2A is 5A. What do we get? So I've got 5A equals 10. A equals what? 2. Okay? So now we go back and compare it. What is it?
So is it like the no solution?
This is no solution. Yes, you're absolutely correct. Here we've got A cannot be 2. And what did I get? I got A equals 2. So I got to do something about that. So my answer to this is no solution. I had to throw that out. I had to throw it out. It's not possible. It's an extraneous solution. Okay? Okay, can I go to the next screen?
Going back to like the formal slide, because I don't know how you got 11.
Say that one more time.
I don't know how you got 11 for the last slide.
Let me do that after class,
Okay.
just so we can make sure. And I'll look at it. I'll show you.
Okay.
Okay. Can I move off this one now? Oh, no. Yeah, no, that's the one I want. Okay. So what I want you to do, I want you to determine what X cannot be, and I want you to determine my LCD. That's what I want you to do right now. What can X not be, and I want you to determine my LCD. X can't be what? Good. What's my LCD? Good. Okay, so I've got to account for this by writing down the 7. Then I've got to account for X plus 3. Okay? So now I am going to multiply everything times these 2. And I'm not distributing that 7 yet. I'm not distributing that 7 because in some of this it's going to cancel out. By design, we want it to cancel out. Okay? So I have 7 times X plus 3 over 1 times X over 7 equals 7 times X plus 3 equals 4 over X plus 3. Okay? Now, I'm simplifying. I have my 7 and my 7. What am I going to have to do with that X? Distribute. Okay, so I'm going to have X times X plus 3 equals 7 times 4. Okay. Now, I know what to do here, but we're moving into having quadratics that we have to solve. We know how to solve quadratics, so that's okay. X times X is X squared. X times 3 is 3X. And 7 times 4 is 24. Now, I am solving a quadratic. It is 28. Sorry. Okay. X squared plus 3x equals 28. Now, because we are solving a quadratic, what do I have to set it equal to? 0. So I've got to subtract 28 from both sides. Okay, so I am subtracting 28 from both sides. So I get x squared plus 3x minus 28. Okay? How do I solve a quadratic that looks like this? What do I have to do? Factoring is not going away until after spring break. It goes away after spring break, but not before then. Okay? Okay, my product is negative 28. My sum is positive 3.
So would it be 7 minus 4?
It would be 7 and negative 4. Good. The 7 is positive because your sum is positive. One's positive and one's negative because your product is negative. Okay? So I get x plus 7 equals 0. X minus 4 equals 0. Okay, so I have to compare my answers to what x cannot equal. Do I have to throw anything out? No, I don't. I don't have to throw anything out. Okay. Okay. Can I move off this screen? Okay. Now, this one takes it a step up. This one takes it a step up. What you have to do first here is factor the denominator. We are going to factor the denominator. We have to factor that first. Then we are going to determine what x cannot equal. Then we are going to determine the LCD when the denominator is in factored form. Okay? So we have to factor the denominator. Factoring is not going away. Okay? So I have x over, I can pull out an x right there. I can pull out a 2. So I factored out the GCF, and my GCF was 2. Okay? What is x squared minus 16 factor 2? Good. Yeah, you're right. Okay, that's a difference of perfect squares. Okay, so I factored my denominator. Now, I have to set x minus 4 equal to 0 to determine what my value can't be. And what do I have right there? Yeah, an x plus 4. So what can x not be? Good. Okay. So here I would get positive 4. Here I would get negative 4. So x can't be positive 4 and x cannot be negative 4. So those are the values that I've got to look for. Okay, now I've got to make sure that 2 is part of my LCD. So I'm going to write down 2. Then I've got to make sure x minus 4 is part of my LCD. Okay? Do I have x plus 4 as part of my LCD yet? No. Okay. Now, and do I have x minus 4 already? Yes. So I don't have to write that down again. Okay. So I just had to factor that stuff first. That's what I had to do first, was factor. Now, I'm going to multiply everything times my LCD. And my LCD is a little larger. So I've got 2x minus 4 times x plus 4. And I know that's difficult to see right there, but I'm going to write it out several times. Okay? So I'm going to multiply everything times this. 2 times x minus 4, x plus 4, over 1 times x over 2x minus 4. Okay? And we've got to do it 2 more times. 2 times x minus 4, x plus 4, over 1 times 16 over x plus 4, x minus 4. And the reason that you don't multiply these things out is because some of this stuff's going to cancel. So you don't want to multiply out your denominator, your LCD, until after we've done all this part. Okay, 2 times x minus 4, x plus 4 over 1 times 1/2. Okay. And thankfully, some of this stuff cancels out. Okay? Here, I've got a 2 and I've got an x minus 4. Okay? I'm left with x plus 4 and x. What am I going to have to do with that x? Distribute. And we know how to do that. Here, I've got x plus 4, x minus 4, x plus 4, and x minus 4. So I have 2 times 16. And here, I'm left with x minus 4, x plus 4. Now, we know how to solve this. We know what we're doing. Okay? X times x is x squared. X times 4 is 4x. 2 times 16 is 32. X minus 4 times x plus 4, you can do it off to the side, but we already know what it is, right? Difference of perfect squares. If you need to FOIL that off to the side, that's fine. Okay. Do you see how I have an x squared on this side and an x squared on this side? I need to deal with that first before I deal with anything else. Okay? I need to get those on the same side. When I do that, what happens? What happens? They cancel. So x squared minus x squared is 0. X squared minus x squared is 0. Okay? And at first you may be like, oh, what do I do? But they actually did us a favor, because what do I have left now? What is that? Is that a very doable equation to solve? (4x plus 32 equals 16. Do we know how to solve that? Okay. Thank you. Okay. Subtract 32 from both sides. 4x equals negative 48. Okay, when I divide both sides by 4, I get x equals negative 12. Okay, so x equals negative 12 is the answer to this. X equals negative 12. Is that one of these that I had to throw out? Nope. Okay. If you haven't finished writing this down, go ahead and take a picture of it, because I've got one more I want to do and we're running short on time. I can come back to it if I need to, but I do need to go ahead and get started. Okay. Okay. So here we go. We've got 2 plus 4 over x minus 2 equals 8 over x squared minus 2x. Okay? One of the things that I want to do is I want to put that 2 over 1. Okay? So that's one of the things I'm going to do first, is I'm going to put that 2 over 1. Okay? Then I'm going to factor anything that needs factoring. Now that x minus 2 does not need factoring, but does x squared minus 2x need factoring? What do I need to pull out of that? X. Okay, so first thing I'm going to decide, what can x not equal? X can't be 2, because if I put x minus 2 equal to 0, I get 2. Not allowed. 2 minus 2 is 0. What's my LCD? X minus 2 and what else? Times x. Excellent. You guys are doing great with that. Good job. Okay. Now, I'm going to multiply everything x times x minus 2. Okay? X times x minus 2 over 1 times 2 over 1. X times x minus 2 over 1 times 4 over x minus 2. X times x minus 2 over 1 times 8 x minus 2. Okay. Can I cancel anything out of the first term? I can't. I've got x times x minus 2 times 2. I actually have to distribute two things. What do I have to distribute? 2 and the, good. Okay, so I'm going to write this. So I have my 2 here and I have my x here. So I'm going to write that as 2x. Then I'm going to write my x minus 2. So I've got to distribute that 2x right there. Okay, x minus 2 and x minus 2 leaves me with 4x. All of this cancels. Okay. 2x times x is 2x squared. 2x times negative 2 is minus 4x. Okay. I am left with 2x squared equals 8. Now this is a quadratic, and we have to set quadratics equal to what? 0. Okay, so I'm going to say 2x squared minus 8. I just moved that minus, that 8 over. Okay, I've got a 2 that I'm factoring out. X squared minus 4, what is that? Excellent, it's difference of perfect squares. Okay, so now when I set each one of those equal to 0, I get x plus 2 equals 0, x minus 2 equals 0. I have x equals negative 2 and x equals positive 2. What can x not be? Positive 2. So I have to throw this out. Is it okay that x is negative 2? Yes. So my only answer here is x equals negative 2 because I had to throw out my x equals 2. So sometimes you have one answer and you don't have the other. Okay?